So, tetrahedron ABCD has AB equals 5, AC equals 3, BC equals 4, BD equals 4, AD equals 3, and CD equals 12 over 5 times root 2. What is the volume of the tetrahedron? We have A, B, C, D, E, 5 options here, and this is 2015 AMC 10A problem 21. So before we dive cluelessly in this problem and get stuck, we'll just look around for a bit of clues. So let's just first draw the tetrahedron, because obviously this whole problem is about the side length, and that's the only clues that we have, so we should probably draw those clues out and visualize them. So AB. So that's A, that's B. And then AC. That's AC. I'll make it a little longer. Okay, so that's AC. Then BC. Like that. So let's just label the side length first. So AB is 5, AC is 3, and BC is 4. Now, do you notice something that looks weird here, that looks familiar? Well, obviously it's a 3, 4, 5 triangle, which means that this angle, angle C, is actually a right angle. So that's actually great. We've got an extra clue. Now, BD is equal to 4. So I'm going to assume that's BD. Right, and then AD is 3. So I'm going to connect AD. That's 3, that's 4. And that's a right triangle. Again, so ABD and ACB are both right triangles, and they're congruent to each other. That actually looks kind of great. Okay, so now what about CD? So this is actually a 3D graph, right? So I want you to imagine that this is actually a 3D graph. So what I'm going to do right now is I'm going to erase this, and I'm going to squash the triangle ABD a bit just so that it looks 3D-ish. Like that. So that's 3, and then that's a right angle, and then that's 4. This point is D. Okay, so that looks more 3D-ish. And CD is 12 over 5 root 2. Now, what's the point of 12 over 5 root 2? There has to be a purpose of this, because if CD was just a random side length, then it could have been 10 or 20 or, I don't know, 10.5, right? Why does it have to have root 2, and why does it have to have a rated fraction? We don't know. But this obviously has some purpose of setting CD equals to 12 over 5 times root 2. Now, let's just look at CD for a moment and see and try to figure out what the purpose of making CD equals to this real number is. Now we realize that 12 is actually 3 times 4, right? So that part is actually 3 times 4 over 5. So that kind of looks familiar, but we can't recall where it is from. So it's from the right triangle somewhere, but where is it from? We don't know. And also the root 2. What's the root 2 got to do here? So is it trig, or is it the Pythagorean theorem? We don't know either, but we have a few clues. So firstly, there's probably another right triangle we got to find for the root 2 thing, and also we have to have something related with the 3, 4, 5 right triangles. So to make a right triangle, let's just try and draw the heights, because essentially what we want to do to find the volume of the tetrahedron, even if you didn't figure out that CD has a purpose of being this weird number, if you think about it. Okay, so I want the volume of the tetrahedron. The formula for the volume of the tetrahedron for any tetrahedron is base times height times 1/3. Now the base, we already have the base. The base is just 3 times 4 over 2, the area of this triangle. That's 6. We only need the height, so where's the height? We want to figure the height out. So maybe we can start out by drawing the heights we already know about, like this. So I'll draw the heights like that, and they meet at one point because these two triangles are congruent, and therefore there's some symmetry there. You can prove that on your own, but just know for now that their altitudes indeed end at the same point. So let me just call that point E. So that's point E, and we know that C and D are equal. Now, can we figure out C and DE? It might be some help, right? So what are C and DE? So CE equals DE. And what are they equal? Well, essentially we know the area of triangle ABD. It's 3 times 4 over 2, which is 6. And we already know that this side AB is 5. So 5 times the height over 2 must be 6. So the height is equal to 6 times 2 over 5, which is 12 over 5. So, surprisingly, this is actually the height of our triangles, the altitude of our triangles. So this actually proves that CD kind of has a purpose of being that weird length. What about root 2? Well, just look at this relationship. So we know that CE and ED are both 12 over 5, and CD is 12 over 5 times root 2. If you actually use the Pythagorean theorem there, we know that CE squared plus DE squared is actually equal to CD squared. So this means that this angle here is actually a right angle. So triangle CED is a right triangle. So we have 3 right triangles in this tetrahedron now. And actually, since we know that CE is perpendicular to ED, and we also know that CE is perpendicular to AB, because the purpose of CE at first was to serve as the altitude on side AB. Since AB and ED are different line segments, 2 line segments decide a plane. They form a plane. So this plane over here. So the surface ABD. So actually, we already know that CE is the altitude of tetrahedron ABCD. And why is that? Because essentially what the altitude means is a line segment that starts from this point, the vertex of the tetrahedron, and it's perpendicular to the base of the tetrahedron, and that actually CE actually fulfills our requirement. Now that's actually great because we know CE, right? And we know the area of ABD. So the volume of this tetrahedron is actually going to be 1/3 times the area of ABD, which is 6, times the length of CE. The length of CE here is 12 over 5, so that's 12 over 5. So if we do the math, we can cancel this out and get 2. So we have 24 over 5, so that's our volume. Now, is that an answer choice? Yes, it is. And if you check back our working, I don't think we've done anything wrong, so that's just our answer, C, 24 over 5. Thanks for watching. The key here is to remember to draw these heights, and also to draw these heights and try to connect CD with other things in the tetrahedron. Thanks for watching. Bye.